Recording. Don't get me off topic. Okay. Let's review really quick how to add and subtract fractions. You have that on day 1 of your assignment. So let's just review. If I want to add and subtract this, what do? I have to have a common denominator. So in this case, the common denominator would be what? 4. Now, technically, is 8 a common denominator? Yes. But it's not the lowest common denominator. We want as much as we can to get the lowest denominator possible. Now, once I find a common denominator, I have to alter whichever fractions are necessary to get that common denominator. So in regards to the 1/2, I have to multiply it by 2, so I get the 2/4, right? Now sometimes you have to change both denominators. In this case, common denominator would be 12. If I want the 12, I have to multiply this by 4. I have to multiply this by 3. And we get 9. Can you still subtract it even though the second one's bigger than the first one? Yeah, your answer's just negative. Oh, yeah, there we go. Okay. Now this has a little bit to do with what we're doing today. The only difference is today we are doing it with variables, not numbers. Now my first example. It told me to. My first example, or set of problems, they already have a common denominator. So all you have to do is add or subtract the numerators. So for part A, the common denominator is 3y. Add the numerators, you get 11 over 3y. Do you have to list the excluded values? No. No, because the problem doesn't tell you to. Thank you. Okay, moving on. Part B. Now there's one thing I want to do to change part B. We don't really like minus, right? Because minus can throw things off. What I mean by that is, hold on. What I mean by that, remember when we were doing adding and subtracting? Like that. What did we do with that negative? We distributed it, right? We couldn't just subtract this and leave the 3x alone. We had to distribute the negative. The same is true. I've got to find my right page. Hold on. No, that's not it either. There we go. The same is true with any sort of negative that's between fractions. Now, there's not really anything to distribute, but I can take the negative up with the x and change that to a plus. I want to. Okay. Ooh, because if you do it at the bottom and on the top, then the negatives would cancel, so it's no longer negative. Yeah. You only do it to the top. And then the other reason, if you were to do it to the bottom, you no longer have common denominator. Y'all okay? Not yet? Almost okay? Okay. All right, so when we have that now, I can combine them. The denominator is x minus 2. The numerator, 3x minus x, would be 2x. That would be my final answer. Does anything cancel? No. You guys okay so far? Now looking at this one, if I use that same idea where the negative has to come up to both of those, what's going to change? It's going to be a negative c and a positive 28. So you have to distribute that negative to both of those pieces. When we combine like terms, we have a 2c plus 7 on bottom, and what on top? 4. It kind of looks like something might cancel here. How do you know if anything's going to cancel? It has to be exactly the same thing on top and on the bottom, right? So if we were to factor out a 4 here, what are we left with? C plus 7. Is this exactly the same thing as this? No, it's close. Do you agree that it's close? But not exactly the same. Because it's not identical, nothing cancels. We need to leave it like this. Yes?
Why can't you divide 2
Can't do it. Because of the plus sign. Remember every time you do that, it's... Kills math teachers. Remember, you can't do that. Because of the plus. You can't do it. In order to cancel things, they have to be connected by a multiply. These aren't connected by a multiply, so you can't just, his question is, why can't you just cancel those, make it a 4, cancel that, make it a 2? That gives me high anxiety. You can't do that. Because of the multiply. Those you can't do that. Never. Never shall I never, ever. You can't do that. Never. Ever. Yeah, never. If you can factor stuff out and then have, so now it's connected by a multiply. Because it's connected by a multiply, you can take this entire thing and that entire thing. I'm just going to pause the recording for a minute while I answer all these questions. Okay, number 3, part A. This time, they don't have a common denominator, right? Let me show you what the common denominator would be for part A. Don't write anything down, just watch. That way you don't lose something while your eyeballs are not looking up. The common denominator on this is going to be 6x squared. Now, in order to get this 6x squared, I know it's 6 because 2 goes into 6 and 6 goes into 6. I know it's x squared because that's the lowest thing that both of those could have. Now to get the common denominator, at the end I'll have you write this whole problem down. This one has the 6, it has one of the x's, what does it need? The other x. So I'm going to put an x on both of those. Looking at this one, it has the x squared, it has 2, which is part of 6. What does it need? It needs a 3. So I'm going to multiply the top and the bottom by 3. Now both of those on bottom should have 6x squared, do they? Once they have your common denominator, let's simplify the top. 5 times x is 5x. Multiply those, plus 9, you are done. Write it down. Okay, I'm okay if you don't understand on the first time. That's fine with me. I'm not okay if you don't understand on the 20th time. But if you don't understand on the first time, that's fine. As we do more and more problems, I promise it's going to get easier. Try not to block it off and say, I don't know what you just did, and then stop trying. I promise, as we try more, it's going to get better. Anna? I mean, you should see, well, you can't actually add it because they have different terms. If anything were to factor out of this, though, that I would try to see if something's going to cancel in the end. But in this case, nothing does. Okay, part B. The first thing I'm going to do is I'm going to take that negative and make the 2 negative and that a positive. You okay with that? Always do that first. Now let's look at the common denominator. Between the 7 and the 3, it needs to be 21. Y to the 4th, y squared. Common denominator, y to the 4th. Because I could change this one so it has 4 y's, right? I can't really change that one so it has 2. I can up the amount of y's. All right, if that's my common denominator, looking at the first one, it needs a what? To make it 21, it needs a 3. And it has all of the y's that it needs, right? I multiply 3 on bottom, I've got to multiply it on top as well. Looking at my second group, it needs a 7 and the 7 will make it a 21, combining with the 3, and then y squared would be y to the 4th. Do you agree? You add the exponents, yeah. So, final answer here. Simplify the top. 3 times 3 is 9, minus what? And then check really quick. Can you factor anything out of the top? No. So you are done. Was that one a little bit easier than the first? Yes. We talked about it before you got here. Yeah, ask him why he had to transfer out of his class. Nope. Okay, moving on. Yep. Not my business to tell. Part C. Oh no. Part C, common denominator? What is the story that he needs to tell mommy?
I can say I no longer have movie We're recording. I like Corey. I wish he were here still. Okay, we're gonna talk about it.
I'm not telling anything more. I like Corey and I think he's great. I wish he was still here, but he's not. Let's move on. I've had the same combination of you all transfer out too. I like you, and I wish you were here. But don't transfer, because that makes you mad. Okay, common denominator is what? 10x to the 8th. In order to get 10x to the 8th first, do you agree? In order to get 10x to the 8th, the first one needs what? A 2. It already has all 8 of its x's. The second one, to get to the 10, it needs a 5. To get to the 8, it needs x to the what? X to the 6, because you add powers. You don't multiply. You add powers. So, do they both now have 10x to the 8? Yes. What is the top simplify to? 12 plus 20x to the 6. Now pause really quick. Can we factor the top? Is there something that can go into each of these terms? What? A 2. So each of those terms are divisible by 2, which means we need to factor a 2 out of all of them. Yep. Yep, if they're all even, that's fine. So factoring, if I want to pull a 2 out of this, it would be what? 6 plus 10x to the 6. If I pull a 2 out of the bottom, it would be 5x to the 8. That's a step that's not really necessary. I just want to show you I can pull a 2 out of both of them, and 2 over 2 is what? 1. So my final answer would be this. I don't want to rewrite. Does that make sense? Yes, I want you to simplify it if you can. So this is why finding the lowest common denominator is so important, because when you find the lowest common denominator, you don't have to reduce as much. If you're going to reduce, it's probably simple and small like this. Okay, let's do one more and then we'll take our 3-minute break. This one looks different. How is this different than this one? Because of the plus. This is a binomial instead of the monomial. Now, I just want you to watch what the common denominator is on this one before we move on. The common denominator will be this. You have to take the entire factor and multiply it by the other entire factor. So it's not like I'm going to have an m and minus 2 and a plus m or whatever. You take the entire group and multiply it by the entire group. Now, we will. On the bottom we won't, but on the top we will. This is the common denominator. So just watch for a minute. On this first one, it has the m plus 2. It needs the m minus 7. Hold on. On this group, it has the m minus 7. It needs the m plus 2. So that is how I'm going to adjust my fractions. So this is the common denominator. Now, I can simplify the top. I can't just multiply like this, because that was just one number. How do I simplify this? No, because then if I did, it would be the exact same problem. Like that's what, yeah. Let's distribute those. So you have 9m, hold on, 9m minus 63 plus, now let's distribute this one, 8m plus 16. So we distribute here, and then we combine like terms. So when we combine like terms, we get what? 17m minus 47, I don't know, what is it? Somebody all have calculators, I don't, what is it? 47 all over m plus 2, m minus 7. Now you have to check it. Does anything factor out of the top? No. Do you want to multiply those together? Me neither. This is your final answer. I know I said after this one we're going to take our 3-minute break, but because this is sort of new, I want to do one more and then we will take our 3-minute break, okay? I just don't want to come back and be like, okay, I don't remember what we just did. So let's do one more really quick. Looking at the common denominator for part E, what will it be? E minus 1 times E plus 2. It is a subtraction problem, so what do we do to the negative? Bring this negative up with the 2. Okay, on your own, see if you can change these fractions using the common denominator. Okay, looking at that first fraction, what does the first fraction need in order to have this as the denominator? Yes, the first fraction needs a what? A d plus 2. The second fraction, in order to have this as your common denominator, needs a d minus 1. Questions with that step? Nothing? Okay. Now what do? They have the same denominator. Let's simplify the numerator. Let's simplify that first one. What do we get? 3d plus 6. Distribute the next one. You get minus 2d plus 2. Now what do? Combine the like terms. 3d minus 2d would just be d plus 8 on top. d minus 1, d plus 2. Does anything cancel? No. Can I cancel those d's? No. Ever? No. This is your final answer. Okay. It is 132-ish. F. Try to come up with your common denominator on part F. Common denominator on part F. Is that okay? Good, I'm glad. Now this minus needs to do what? Turn to a positive, come up with a 4. Now if I'm looking at this grouping, the first term needs what in order to have this as your common denominator? A c minus 2. So you multiply it to the top and to the bottom. Is there value in writing this step down? Yeah, I mean, I would say unless you've been doing this for a while, don't skip this step. You're more likely to make a mistake. This term needs a what? A 3c minus 1. Okay, so now it has a common denominator. What do we do on the top? Distribute, sure. So c minus 2c is the first one. Is that okay? No, I made a mistake. What's my mistake? C squared, good. Looking at the next group, negative 4 times a 3c would be negative 12c what do you do? Good. So c squared minus 14c plus 4. I'm going to ignore the denominator for a minute. Did I screw up? Okay. Ignoring the denominator for a minute. Can you factor the top? That's the next question. You need to check to see if you can find anything that multiplies 4 and adds 14. No, right? 4 and 1. So you need to see if the top factors. If it does, you factor it. If not, you just keep going. And that is your final answer. Yeah, if you can factor the top, you need to, because if you could factor the top, you might have something cancel. But if it doesn't factor, you just leave it. Anna? The 2 and the 12, you can still cancel it. How is part G a little bit different? It's a trinomial, not a binomial, right? So you need to play the game with the denominator here. We're looking for two numbers that multiply to a negative 6 and add to a negative 5. Raise your hand when you know what it is. So x what? Minus 6, x plus 1. Did I screw up?
I came up with a 2 and a 3.
The 2 and the 3 wouldn't work because you wouldn't get the negative 6. If that was a plus 6, then 2 and 3 would work. No, I'm always wrong. Not always. I'm sometimes wrong. So you're fine. You're good. There's one girl, see, my A3 class sees me before you do. There's one girl in my A3 that looks through my answer key and almost every time it's a voucher, and then she'll be like, this is wrong. Sorry. Anna does it too a lot. Isn't this wrong? Yes. I'm wrong. No, I'm wrong. Now, what would the common denominator be here? This is very similar to this case, where we only had to change one of the two fractions, right? Look at this again. They already both have an x minus 6. So do I have to multiply this one by an x minus 6 again? No. I only have to multiply this one by an x plus 1. Because once I do, aren't the denominators the same? Yeah. So my common denominator will be x minus 6, x plus 1. What about the numerators? From here, nothing changed, right? Uh-huh. Once you have a common denominator, you can combine the numerators. On the second half of the fraction, distribute that 2. What do you get? Plus 2x plus 2. Now what do you do? 3x plus 2. Anything else? Can you factor the top? That's it. All right. H. Scoot as far as you can. Start by factoring everything. How loud is my animal? Part H. The first one factors to what? X minus 2, x plus 2. The second one factors to x minus 4, x plus 2. So the common denominator, they both have an x plus 2. This one has an x minus 2. This one has an x minus 4. Is that okay? Yes.
So you look, and I would probably write down what do they have in common first, and then what does one have that the other doesn't, and then what does the other one have that the first doesn't.
Questions on the denominator. They share this one. We list it once. One has this one, the other one has that one. Correct. Because it's already there. So now I'm changing my numerators. This one has the x minus 2, the x plus 2. It needs what? An x minus 4. This one has an x minus 4, x plus 2. It needs the x minus 2. Now I didn't do something with that negative, should I? Let's make it a plus and bring it up with the 3 so that when I distribute, the negative goes through both of those terms. Looking at the first place I can distribute, what do I have? 5x squared minus 20x. Is that all right? Looking at the next group, minus 3x plus 6. Combine my terms. 5x squared minus 23x plus 6. Does that factor? We sure hope not. Nobody wants to.
You find two numbers that multiply to 30 and add to 23. Multiply to 30, why? Can you find two numbers that multiply to 30 and add to 23?
No, so it doesn't factor. That's a good thing. We don't want to factor it. What am I going to put this over? Yeah, you could, but I don't want to. Okay, we're going to pause for a minute. On day 1, you had 3 different story problems. I guarantee that one of those 3 were going to be on the test. On this one, there are 2 more types of story problems. They're very similar, but one of these will also be on the test. So you're guaranteed at least 2 story problems on the test. Which is why you want a free test question, right? Get all everyone working outside. Okay, number 4. A certain truck gets 25% better gas mileage when it holds no cargo than when it is fully loaded. Does that make sense? You got a truck, it's full of stuff. Do you think it's going to get as good of gas mileage as when it's lighter? The heavier the truck, the worse the gas mileage. Is that fair? Okay. A certain truck gets 25% better gas mileage when it holds no cargo than when it is fully loaded. Let M be the number of miles per gallon. That sounds probably like it's an important thing. Of gasoline the truck gets when it's fully loaded. So when it's loaded, my gas mileage is M. Now if I have a better gas mileage, the M's going up. If I have a worse gas mileage, the M would go down, right? So if M was 25, if it has a better gas mileage, M goes from 30, 40, 50, so on. Okay, the truck drops off a full load and returns empty. So the truck goes somewhere, and then when it comes back, is the gas mileage better or worse? Better, because it's empty. What is an expression for the number of gallons of gas the truck uses if you traveled 80 miles in one direction? Well, the first thing is you have to figure out how many gallons of gas you use. Like, what's the equation for that? If I want to know how many gallons my tank uses, what do I need? I need to know how far I go. I promise to look at it. I want to figure out how many gallons I'm using. What equation is that? And you know how far I go, and I also need to know my gas rate and miles per gallon. Now I'm going to organize my data into a little chart. This truck's driver is going fully loaded, and then it's coming back empty, right? We need to know each of these things. We need to know how far the truck driver went, the distance. We need to know his rate, or his miles per gallon. And we need to know how many gallons he used. I promise I would not be working on the homework right now, or you're not going to understand this. I guess paying attention when you're not understanding it. Okay, what can we fill in our chart? Do we know how far the driver went? 80 miles. So fully loaded, they go out 80 miles and they do what? Come back 80 miles. Any questions with that step? Now it tells me right there, let M be the number of gas miles when he's fully loaded. Where does the M go? Top or bottom? Top. Now you told me when he comes back, he gets a better gas mileage. Do you agree? Because he's going to be empty. Now how do I let this affect that gas mileage? Well, it's no longer going to be M. It's going to be 25% more, right? Isn't that what that means, right? 25% more. What decimal is this? Because it's 25%, and look, I mean, it's 25% more. That's what that would be. Because I have my gas mileage that I'm increasing it, which is why it's a plus, by 25%. Okay? Now, if I want to write an expression just looking at the top for my gallons that I've used, I'm going to use this equation. I need to know the distance I traveled divided by what? My gas rate. Looking at the bottom, same thing. If I want to write an expression using these two numbers, I need to know the distance that I traveled divided by the rate. So these two right here, those are individual expressions. Is that okay? Again, this is the first time you've seen it. I don't expect perfect clarity. But we need to do what? What is an expression for the total number of gallons the driver uses? So I need to come up with an expression combining those two. Will I add them or will I subtract them? I would add them. Good. Let's try that. So I've got 80 over M plus 80 over 1.25M, which is how this corresponds to what we're doing today. If I want to add those two together, what do you need? A common denominator. Now they both have an M, right? This first one, however, needs a what? A 1.25. What's 1.25 times 80? 100. So let's rewrite that as 100 over 1.25M. We're going to get what? I multiplied those two numbers. Over 80 divided by 2.5n. Do they have a common denominator? Yes, so you can add the numerator. Sorry, I'm coming up here. I'm running out of space. Add the numerator, 180 over 1.25m. Now there's a little rule in math that you can't mix decimals and fractions. So that means I have to get rid of my decimal. The first thing I'm going to try is 180 divided by 1.25, a nice pretty number. Try it. And look at this, we're down, we don't have to do anything more. 144. So this simplifies by dividing these two to 144 over m. Because I divided by 1.25, the 1.25 goes away. Ooh, that's a lot of color. I think number 5 is a little easier than number 4. They're kind of the same concept though. Let's do this again. Now if you look at number 4 on the notes, this one corresponds to number 13 on the homework. So you'll do number 4 just like you do number 13. Just like you do number 5 on the notes and 14 on the homework. So let's do 5 really quick. Oh, I didn't know I have like 0 to write that. Look at number 5 really quick. On the back. You can look it over. Okay, this one This one's almost identical, slightly different formula. A bicyclist, I say that wrong, bicyclist, whatever, rides 5 miles out and then rides back. His speed return is reduced by 20% because it is raining. Makes sense, right? You're going to go slower if it's raining. Let R be his speed in miles, so this probably is important, when riding out. What is an expression that represents his total time in hours riding out and back? So you need one formula. Distance, how far you go, equals how fast you go, with miles per hour, times however long you are traveling. So if I'm traveling for 2 hours and I'm driving 50 miles per hour, how far did I go? 100, right? R stands for your rate. Miles per hour and miles per minute. Okay. Now back in the olden days when we used to take vacations, we didn't have a GPS that says you will arrive in 42 minutes, whatever. We would figure out, like we would pass, now maybe not we, I would because I can, would pass those little green signs on the side and we're like, oh, 42 miles until we reach Salt Lake City. Dad, how fast are we going? 80 miles per hour. And then I'd like figure this out because I want to know how long it would take me to get home. I did that. It was really funny because I do that. I didn't have a phone that would do it for me, but that's what your phone does. Now, we need to write an expression that deals with the total time, which means we need to solve this equation for time. If I want to solve this equation for time, what do I do? Yeah, I'm going to divide by my rate, or kind of my speed is a good way to look at it. So time is your distance divided by your speed. So just like we did before, let's come out with a chart. This kid's riding his bike out, and then he's riding his bike back, right? Or bike. In which of those cases is it raining? So this is where it's raining, right? So is this one slower or faster? Slower. We need to know the distance. We need to know the speed or the rate. And we're going to come up with an expression like this that has to do with the time using this equation. Now, how far did the kid go? 5. He wrote out 5, he wrote back 5. Let R represent his speed. Where does the R go? Does it go to the top or the bottom, and how do you know? R being his speed in miles per hour riding out. The R goes here. Now, is his speed reduced or increased riding back? It's reduced. Now on this one, it was increased, so we added 0.25. Because this one's reduced, what do you think I'm going to do? Subtract 0.2. Why 0.2? Yeah. So how did I get this? I said, well, my speed was R, but I'm subtracting 0.2R because I'm going slower. I'm reducing it. That's how I get the 0.8. Sorry, it's slow. Give me a second. Is that better? Is this a reduction of 20%? Okay. Now, if I want to come up with an expression dividing those, in terms of time, it's distance divided by rate. 5 divided by R. What would this bottom one be? Now, if I want to come up with an expression that deals with the total, that's not what I meant. If I wanted to come up with an expression that deals with the total, what do I do? Add them together. 5 over R plus 5 over 0.8R. Now what? Yeah, Chris? Fantastic. Oh, except for I hate this. My kid always walks home in the rain. Okay. I have to multiply both fractions by what? By 0.8. Why? Because they already have an R, we need a common denominator. 0.8R on bottom. What is this? 4. And 4 plus 5 would be 9. Questions here is how you would simplify this if it does not divide nicely. Could I multiply this by something to get the decimal to move over one spot? If I multiplied it by 10, I would, right? And then the decimal would be gone. If I multiply the bottom by 10, I have to multiply the top by 10. And when I do, you get 90 over 8r. So now the decimal's gone, but we created a new problem. It's not what? It's not what? Simplified. So they're both divisible by what? 2. Let's divide the top and the bottom by 2. And you get 45 over 4r. There you go. That's all. Thanks for suffering through this with me. Peace out.